Hi, my name is Brian Sane. I am a .NET developer, and I have been working with Akka Net for about the past 4 years. And I wanted to make this video so I could kind of lower that threshold of introducing people to Akka Net. When I was working with it and learning with it about 4 years ago, it was a little daunting and overwhelming with all these new concepts. And so I wanted to add a video. Let's make this easy. Let's make this inclusive. And this video specifically is to help kind of get you a baseline of what Akka is, what an actor model is, what are actors, and all those things. So you can move forward and go to do different tutorials. I will be making more for Akka clustering and Akka persistence, but for now, baseline. And here on the screen is a GitHub pages that I've made for just some of my notes on Akka.net. I did the basics section and I'm going to be adding to that. And then after Akka.net, I'll be making more videos and including more things outside of that to really try to help people get into development, but specifically for developers switching technologies and things like that. But right now, we're doing Akka.net and it's going to be fun and great. Let's get to it. So what is Akka.net? So Akka.net is a open source project and it allows us to implement the actor model architecture. And I'll get into the actor model here in a second, but Akka.net specifically is a port of an existing project called Akka, but it is built specifically for C# and F# for .NET projects. It was founded and primarily it is maintained by Petabridge, Aaron Stannard over there, and they are a great company, worked with them a lot of times, and if you see most of the documentation for Akka.net has Petabridge all around it, and that's great. They're a good company, but that's kind of why. I was confused on who Petabridge was. That's who they are. But specifically, Akka.net, it allows us as developers to build asynchronous and distributed processes. And that really kind of opened my eyes to horizontal scaling versus vertical scaling. Kind of in the old days, if you installed something on IIS, you didn't really scale it horizontally. You couldn't add really more computers to the system to spread computing around. It was okay, well, we need to put it on a server that has a better CPU, better memory, better network IO, whatever. And with Akka.net, it is very easy to set up horizontal scaling in Kubernetes, and I'll probably do some videos about that. But with Akka clustering specifically, it is very nice and it's been great at work because our actor system will receive a batch process and it will be trying to process like 1,000 messages or 10,000 at a time. Well, Kubernetes says, okay, your CPU threshold for this list of actors is above whatever rate we set it at. So then it starts spinning up more and more nodes and pods. And then once that threshold gets down and everything's settled down, it kills those for us. And it's been really nice. Once we kind of got everything set up with Akka clustering and Akka persistent, it has been very reliable and stable so far. So what is the actor model architecture? Well, actor model is where everything is an actor, right? So you could have a saga, which is a long running process, or you want to communicate between two different actors. But an actor is like its own entity. They're really kind of independent entities. And that's helpful if you have, specific business logic or you want to implement domain-driven design where you have a specific section of the business and you say, I want a domain of customers. I want a domain of a warehouse. I want a domain of X, Y, and Z. Well, with domain-driven design, you can do that. You can silo everything to one thing, and with an actor system specifically, it really helps ease that because you could have your customer's actor, and nothing else can, call those methods and execute them. Instead, actors communicate by sending messages, and then only my customer actor will actually be able to update the object, set properties, do all of those fun things. Um, and you don't have to have just one actor. You could have customers actors, where customer Bob is one actor, customer Joe, customer Donna, whatever, and they're their own individual actors. And that's really cool because there's not really, crossing the streams, so to speak. All of the threads are executed separately, and I'm not worried about, changing Bob and changing Donna and getting references mixed up. It is all just siloed really well, encapsulation and data isolation. But as I mentioned, actors communicate with each other for messages. So each actor has a mailbox, and a mailbox is essentially just a queue managed by the internal Akka system, and it's a first in, first out queue. So I will know that whatever order my actor receives these messages, they will execute in that order. And that's really helpful for, a transactional system. If you want to do banking, anything in finance, stocks, whatever, where it's highly transactional and order really matters. Well, with this queue, it's easy to do that. And messages can really just be anything. It can be a string, it can be an integer, object class, whatever. So the two-way that you send messages to different actors are in tell or ask. Tell is really just fire and forget. You need to know this information. I'm going to tell you, and I don't care if you respond or not. You can process it, you can not, whatever. It doesn't matter to me. I just am supposed to tell you that this event happened. Where ask is, okay, I need this information in order to do my next calculations to proceed forward in the workflow. So I'm going to send you a message and I need a response. I'm going to wait for this response. And, there are use cases for both, but most of the time you want to do a tell. You could even do a tell query an actor state, and then as programmers we will receive a actor state response, but you don't have to ask for it. And that really allows that actor to process more messages if it wants to or if it needs to. It kind of opens that thread with asynchronicity, but there are very good use cases for ask. And when I was introduced, ask was kind of shunned upon, and that's not the case. The whole system by itself runs asynchronously. So each thread or each actor runs in its own thread, but the actor itself processes messages synchronously. Oops. Processes messages synchronously. And that again goes back to, I know my actor is not going to process two messages at the same time. It is intentionally synchronous while the system as a whole is asynchronous. So for your actors, actors can create actors who can then create actors. It's turtles all the way down, pretty much. And what happens is pretty much every single actor has a parent to it. You have the main root actor, you have a user actor, and a system actor. And the system actor you can just kind of ignore. But the user actor, that's where you create all your things. And I'll show you the hierarchy here in a second, but I wanted to kind of just talk about supervision, where the parent can watch whatever child actors it creates. And then if or when that child actor dies, the parent decides, okay, here's what I need to do with it. You just need to push through and resume. It's fine, just ignore it. You need to restart. There's something wrong in your internal Akka state, or let's figure this out, let's restart. You can fully stop the child and just say, hey, I need a user to come in here and restart and re-kick everything off or something like that. Or you can escalate it to the child's grandparent or that parent's parent. And again, it goes through that for process itself. And that's really nice if you want to watch and make sure, okay, that actor died. Why? What message did it receive? Okay, let's restart it and then send that message again. So here's an example of what the hierarchy is for an actor system. You have the root, the system underneath that you can ignore. We don't have access to query it. We don't need to query it. That is all just Akka implementation. From there, you have user, and that is a system defined level, and that is just going to be the ultimate parent, the matriarch or the patriarch or whatever, the actor arc of the system. And under that is where you will create all of your different actors. So if you have a customer actor or a warehouse actors or whatever, they are all created under the user. If you wanted to query and send a message to a specific actor, there's multiple ways to do that. But you can look at this and kind of treat it like a URL for a website. You start at the top of the root and then you do /user, /customer ABCD. If you want to go to that customer's specific shopping cart, you would do customer ABCD or whatever identifier /shopping cart. And, like I mentioned, you can have actors be a implementation of an object. And if you do that, you have to have a unique identifier because you can't have two actors on the same node or route or however you want to define it, branch of the tree, whatever. But underneath that actor, you can have shopping carts. So I have two shopping carts with the same name. However, they're children of a different actor. And that's totally fine because it's a unique route. So sometimes, people want to create it that way. The other way that I prefer is a manager actor. And that is a parent manager that is kind of at the second level, one of the first ones you create, and they receive messages that are supposed to be sent to different actors downstream. The actor manager can watch the life cycle, can do special things like send an initialization message if it needs to, um, whatever. It has a little bit more control of that. It is, kind of acts as a middleman, but sometimes that's necessary. So there you would see its warehouse EFGH or whatever identifier. So if the shopping cart wants to query against a specific warehouse, then they would do, /user /warehouse manager, and whatever message they send will include that unique identifier. That is used, or this pattern is used a lot within the Akka internals itself. And as you kind of dive deeper into the code, you'll start seeing the same patterns just kind of used over and over. So now I wanted to kind of show off my Akka.skeleton project. All right, so this is the Akka.skeleton project that I created. It's available on GitHub, and there's a link in the description of the video. But I created this to be a bare bones project to really lower the threshold and just kind of get working with the actor system. That's how I learn. And a lot of the examples and tutorials have stuff already built, and I wanted to just have something very clear and easy to understand. So we'll just go ahead and get into it. Right here is where you define your actor system. This is akka.hosting, and it used to be a little bit confusing with the Hocon config, but now with this, it creates the Hocon for you. Here's where I just configure loggers. This is just how I personally like to do it. I really like the serial log. You can do log4net, custom logger, whatever you want. Here is where we are actually defining what actors we want in our system. Here is that name that we gave it before. If we do .abcd, we could do that. It doesn't really matter. That's just kind of where it lives in the route of the system. And then we are registering this to the actor registry so that we can use it in dependency injection. And I'll show that here in a little bit. The echo actor is a receive actor, and that's how you define them. It is either receive actor or untyped actor, and there's not a big difference. I just prefer the receive actor. I go more into detail in my notes on the GitHub pages or on GitHub itself. So if you're interested to read about the difference, you can go find that or do Petabridge documentation too. So here we are defining where if I receive a string message, I want you to execute this block of code. If I receive an integer, I want you to execute this block of code. And then I just kind of added a catch-all here. I don't add it for really anything. I just added it for this. And essentially saying, hey, we received this unsupported type. So those are my three kind of message handlers for that. And then lastly, I have this Akka hosted service. And this is to kind of demonstrate telling and asking an actor and how you kind of get to do that. And then you can just add code here if you want to play around with it. So I have the actor registry through dependency injection, like I had said. And then here we are actually getting the echo actor. We are asking the echo actor this message. We're saying hello world, and we're asking, so we're expecting a response. Here we are telling, so that's just kind of like a void. Here you go, here's 42. The answer to everything. I don't care if you know it or understand it. 42, here you go. And then I guess we'll try to confuse it and we'll send it 42.5. And because a double is not supported, we'll see that log message. And then I just added a sleep for 3 seconds. So this will go on for eternity until I stop it. So it's pretty easy. Let me show you once the actor system is spun up, and it is really fast. So here we are seeing that we are receiving messages. We have the hello world. We received 42, and then we received an unsupported type. Here is kind of where the Hokon that I mentioned before, it makes it all for you. It's really nice. Sometimes I've had to go in and add my own like Hokon configuration, but ever since Petabridge kind of came up with Akka.hosting, it's been really nice. So this is it. Thank you so much for watching, and I hope you have a great day.